also am one of the organizers of past conferences, and today we're going to make some biodiesel. We're also going to do some titrating of oil, and then we're going to talk about quality tests. If any of you attended, how many went to John Bush's thing this morning? One couple. Okay, good. So you learned about water and how bad it is, right? We're going to talk a little bit, and if we get a chance, we're going to show you what happens when water gets in fuel and the problems that it causes. One of the biggest issues that we see that it causes is soap. I don't have my whiteboard, so I can't mark the thing out, but basic recipe for those that didn't go: when you make biodiesel, you take waste vegetable oil, you take methanol, or ethanol, depending on your social consciousness lately, sodium hydroxide or potassium hydroxide. Both will work. We're going to take a strong base. I'm going to give you a really quick chemistry lesson for those that didn't see it. So this is oil in nature. My hand, I have 3 fatty acid chains. I have a glycerin backbone, and this is called a triglyceride. And in nature, any kind of oil, as it naturally sits, looks like this. In fact, if I take one of your hands and I squish it hard enough and I get the oil out of it and I analyze it, it's going to look like this. It's a triglyceride. Okay? Kind of gross, I know, but to make biodiesel, we have methanol here, and our goal is to snip the fingers off my hand. These are free fatty acids and glycerin backbone, and attach a free fatty acid to a methanol. The combination of a methanol and free fatty acid is biodiesel. Fatty acid, methyl ester. Boink, and away they go. That's in the perfect world. So the perfect world, we cut all 3 of those fingers off, they attach to the catalyst, or the catalyst breaks them off, they attach to the methanol, and one biodiesel molecule makes 1 oil molecule makes 3 biodiesel molecules. It's kind of difficult to see, but this is biodiesel, and it's very, very runny. This is oil, and it's not. The reason we make biodiesel out of oil is so that we don't have to modify the diesel engine, so that we can run biodiesel in a diesel engine unmodified, because it's much more less viscous. It runs, okay? Well, the glycerin molecule is part of that stuff that gums everything up, and that's why we want to get rid of it. So that's why chemically we're removing these and attaching them to methanol to make biodiesel. So we're going to make a little bit of batch of biodiesel. Unfortunately, in nature, as biodiesel, as oil chemicals or oil goes about, it tends to rust and it loses fingers. One of these fingers comes flying off, and now I have what's called a diglyceride. And if it sits around in nature long enough, we lose another one. Now I have a monoglyceride, 1 fatty acid chain to a glycerin backbone. Well, where did these go? They didn't go anywhere. They're still floating around in this oil. Well, how do we get rid of them? For those that attended the chemistry thing, what we do is we figure out how many of those free fatty acids are floating around in this oil, and we neutralize them with a strong base. How many of you have ever made a volcano out of lemon juice and potassium, baking soda? Anyone ever done that? You're taking an acid, you're taking a base, pouring them together, and you're neutralizing them into something completely different. That's all we're doing when we neutralize fatty acids in biodiesel, which we'll get to, okay? So, unfortunately, free fatty acids that have broken off are funny little buggers, in that they like to come after our catalyst really, really quick. And acid and base like to react real quick. The combination of a fatty acid and a base is soap. We don't want soap. We want soap gone, or we want to get rid of it so that we can still get biodiesel. Unfortunately, the fatty acids like to attach this stuff so fast that if you've only put enough in to make biodiesel and not counteracted enough to neutralize your fatty acids, you're left with partially converted oil, some biodiesel, and a little bit of soap. So what we're going to do is something called a titration, and a titration is nothing more than counting the fingers that have fallen off the hands in the oil. I know there's a lot of, you got to see the real deep chemical part about it earlier today, but in a really simplified version, we're just counting how many fingers are falling off in the oil, and we call those free fatty acids. So to get started, we need to make up a known basic solution that we can use to measure, to neutralize acids. And what we do is we count how much of that basic solution we've used, and we know what it relates to in acid content. And so we're going to make a titration solution using 1 liter of distilled water. And if you can see that up on the, it's kind of hard to see, but I'm doing this part right here, the prepping the titration. Okay? Actually, I'm making a titration solution. So I'm going to take 1 liter of distilled water. I'm going to measure out 1 gram of potassium hydroxide. When you make biodiesel, it's important that you titrate with the chemical that you're going to use to make the fuel. So if you're going to make it out of sodium hydroxide, you need to use sodium hydroxide to make your titration solution. If you're going to use potassium hydroxide, you got to use potassium hydroxide. You can kind of do one and the other, but it gets real weird because we run into problems with purity of chemicals. Okay? So what I'm going to do here, I just have a tiny little scale. It measures very accurately. And I'm going to measure out 1 gram of potassium hydroxide. I've got 1 liter of distilled water. I'm going to pour it in this bottle. I'm going to shake it up real good. And this is going to become my known base amount. The amount, it's a mild base that you can then react the oils, or the acids in your oil, and figure out how much catalyst you need. Okay? Just so you're aware, all these 2 documents I'm going to be referencing today will be online. Also, if you send me an email, if you got a pen, info@utahbio.com. I'll email them to you, and I'll email it to you tonight. So if you'll shoot me the email tonight. Also, for those of you who would like to have a lot more education on biodiesel, I have a DVD put together by a guy named Lyle Redenzi. He's a master's in education. He's been teaching for years and years, and he's also an incredible educator of biodiesel. And he threw together a DVD. It's 2 DVDs. It's about 6 hours worth of classroom training. Everything you see here and much, much, much more. If any of you are interested, I'm going to have them here today. They're $40. You can also get them online on our website, but that's that. Also, if you go to utahbio.com, I have a lot of tutorial videos. They're YouTube, they're free, you can go and watch them. I also have tutorials on how to make all this stuff, but don't feel like you have to learn everything today. Today's just kind of a demo to give you an idea of what it takes to make the fuel. Okay, so back to our titration solution. I've got 1 liter of water. And can I just say, I wish the United States would get with it and start using everything in liters. It's so much easier. Although I've got the conversion master, it's 3.785 liters to a gallon. I use that every, huh?
US or Canadian gallon?
US gallons. US gallon.
Have your own gallon.
Yeah, gosh, you know, I was just talking some about that today. So I'm using a cup to do this just because it's easier, and I've got gloves on. Whenever you play with the caustic itself, gloves on. This is pretty nasty, it does burn. And all I'm doing now is I'm just going to measure out 1 gram. If you have high humidity in the area that you're doing this at, it's a good idea to do this inside in an air-conditioned room. The reason is this stuff is so reactive that it will melt. It'll absorb the water right out of the air. So there's 1 gram. I'm gonna actually pour this in my bottle halfway. So I'm gonna put half of this liter of water into the bottle. Then I'm gonna mix my catalyst in. Then I'm gonna put the rest. The reason for that is obvious, it just helps it mix better. And it's also easier than trying to dump catalyst in a very, very full bottle.
Where's your referee?
Not in this one, unfortunately. Actually, something's interesting about this. I can actually drink this. It's that non-potent. It's less basic than soap. I wouldn't recommend it.
There's a lot of things you can't drink.
Huh? There's a lot of things that, yeah. You can drink biodiesel too. It'll give you the runs.
From experience?
Luckily not from experience. It tastes gross though, but not from experience. I have tasted it. I've never drunk enough to get the runs, but if you've ever had castor oil when you were backed up, Biodiesel's oil. Okay, so we're gonna mix that up. Our next step is we need to titrate this oil to figure out how much catalyst we're gonna use. Remember, we gotta figure out, count how many of these fatty acids are going on. So with this out of the way, we're gonna titrate. Again, all the instructions to do this are available if you email me, or if you look on the website, you can actually watch a YouTube video of me doing this as well. I have 3 syringes. Each one of them are labeled for a different purpose. I have one that's labeled alcohol, one that is labeled oil, and one that is labeled titration solution. You can use any syringes you want, but you've got to keep them separate. The reason for that is we're playing with an acid, oil, a base, strong base solution, and you don't want to mix them up and screw them up. We're also going to be using some isopropyl alcohol that we hope is neutral. We'll show you how to test to see if it's neutral. I often get asked how pure the isopropyl alcohol needs to be. Pure as you can find it. Down in the States in Walmart, they sell it in 2 versions, 73%, 91%. 91% works for doing titration. If you're doing soap testing, it's a good idea to get as pure as you can, because the excess water in the isopropyl alcohol will screw it up. Okay, let's talk about our basic recipe to do a titration. You take 10 milliliters of isopropyl alcohol. I'm going to take some of this, just pour it into another thing. A tip I have when you titrate is I never, ever, ever, if I can afford it, draw from the source container. I'm playing with syringes that may have touched some different things, and I don't want to contaminate them if my intention is to later on use the stuff again. Titration is the most important measure in making biodiesel. And it's because if I'm playing with a 100 to 200 gallon batch, if I screw up that titration, I can screw up the whole batch. So this is the most important part. Measuring out the liter of water and measuring out that 1 gram is the most important thing you can do, okay? Okay, so let's titrate. Let's have a little bit of fun. I'm just gonna pour a little sample of this oil in this, and this will be my source container. This is what we'll titrate in. So the basic recipe, again, it's 10 milliliters of isopropyl alcohol. A tip when you're using syringes is you can always get a bubble on the top of this thing. And your bubble is a lot easier to figure out where your mark is on the syringe than the top of the syringe, because sometimes they're convex and it's kind of makes a mess. So I'm going to bring that to 10. We put 10 milliliters of isopropyl alcohol in here. Okay. And then I'm going to put a milliliter of the oil that I'm titrating. If I knew, or if this alcohol was not brand new, there is a way to test your alcohol to see if it is sort of acidic. Because alcohol gets old, it tends to go acidic. And that's to do a titration without adding the oil. You just start putting it in and then you can adjust it. I'm assuming this is new, and in the interest of time, we're going to forego that step. I'm going to do a milliliter of oil. In it goes.
And if the alcohol is neutral, you should only be adding, like,
if it's neutral,
you should be adding virtually nothing in the code.
yeah, if it's absolutely neutral, you know what, we will do one here in a second. If it's absolutely neutral, when you add some titration solution, it should instantly change. Just the tiniest little drop will change it. When you're trying to titrate, it's a good idea that if you're using oils that are thick, like fats, lards, and all of that kind of stuff, to come inside and heat this stuff up. You want the oil to fully dissolve into the isopropyl alcohol. One trick I use is I have a really high heat heat gun, and I'll heat gun my little thing for a second and get it nice and warm before I try and do it. Because in the winter in Utah in my shed, it isn't quite as cold as up here, I'm sure. But it's pretty darn cold and the oil doesn't like to blend.
How warm is warm? Could we just pull that out at reaction temperature? Like 130?
Yeah, you can actually. Temperature really doesn't matter as long as you can get the oil to dissolve and as long as it's not hot enough to evaporate the isopropyl alcohol. You don't want to blow that off. And I don't know what the flash point of methanol is. 148.5 degrees Fahrenheit, but couldn't tell you what isopropyl is. Okay, our next step is we take some of this that we've made and let's titrate.
You haven't added your reference solution yet.
Pardon?
You haven't added your indicator solution.
Yep, I'm just putting some in a cup so I can suck it out.
Oh, okay.
I'm just getting ready to do
Okay.
that. I like to take my little cups that I'm doing this with and label them so that I don't have to do that. This is alcohol. We were using oil here. And I'm gonna use some of this for my titration solution. Pour a little titration solution in here. And again, I'm not going to be using much of this, but this is the most important one not to draw from, because you don't want to screw this up. There. And this is for our oil. This titration solution. I like to pull my syringe up to about 10 to start it. This is 10 milliliters. Again, I use that air bubble on top. Okay, just leave that in there. Titration indicator solution. You can use phenol red from a pool store. You can use phenolphthalein, which this is. Or if you don't have any of that readily available, you can walk on down to your local grocery store and buy a product called turmeric powder. And it works great. We'll show you both titrations. I kind of tend to like it a little bit lately because it goes a really deep red. And we'll show you, we'll do some with this, and then we'll do another titration and show you the difference. How much phenolphthalein should we add? Not much, a couple drops. That's all we need. And how much of the turmeric? Not much. A lot of people get hung up on, oh, did I put 3 drops or 5 drops? My analogy that I use, it's like a cop on the side of the road looking for speeders. You can have 5 cops or you can have 1 cop. They're all going to catch the speeder. And what this cop is watching for is when the pH goes above 7 and into the basic side and changes. This indicates at about 8.5 on the pH scale, as does the turmeric. And phenol red, I think, is either a little higher or a little bit lower. But so it doesn't matter how much. It's just you have to have a little bit in there. So this is our titration solution. I'll just go in here.
No, don't take it off. It's designed to drop.
Oh, okay.
Yeah.
Oh, there we go. Okay. I can't bring stuff like this across the border, so they all have to supply it. So I apologize if I don't look like I quite know how to use theirs. But. Okay. To titrate, you simply start adding measured drops of this stuff into this oil, and we see how many drops of milliliters of this stuff it takes to turn this stuff pink. And this is already starting to turn pink a little bit. There it's coming. See it turning? Oh, this might not be too good. Come on. Wow. Where'd this oil come from? It's interesting when you make biodiesel and you make a lot of it, you get a really good idea of what places you want to eat at. I can walk into a restaurant, and particularly a fast food one, and after you've collected enough oil, I can just tell whether they've changed that oil or not by the smell of the restaurant. I walked into a Wendy's in Lincoln, Nebraska, North Platte, Nebraska, and just about fainted. Okay, this stuff is starting to turn back to a normal color, and the rule of thumb is you want this stuff to turn and stay turned for about 30 seconds. See that deep purple? Okay. So what we do is we started with 10 milliliters and we ended with 6. 10 minus 6 is 4, so my titration value for this was 4. If we had time, we would do this 3 times. And in traditional titration on where you're at, you always like to do it 3 times and do an average. I'm going to do one more because I'm going to do it with turmeric and see how close the turmeric is. Okay. Oil. By the way, just so people can look if you want. Anyone want to take a look at that?
Yeah, you pass it around.
Want to pass it around?
This is NaOH we're doing?
This is KOH.
KOH.
Yep. Anyone know the difference between NaOH and KOH when you make biodiesel? NaOH makes really thick glycerin and KOH doesn't. And you use more NaOH than you use more KOH than you use NaOH. And NaOH, which is lye, is cheaper. So if you want to cut back on your money, use sodium hydroxide, which is caustic lye.
With the KOH, you can compost it and use it in your,
Yep.
you know, in your compost pile.
Yep.
Instead of salt buildup.
NaOH is quite a bit more toxic. And the rule of thumb I follow is potassium hydroxide. Potassium is in fertilizer. Sodium hydroxide. Sodium's in Roundup. You figure that out.
Yeah.
So that's how I kind of remember that.
Why does it make a big difference if you put soap? You want to have soap at the end, the two?
Depends on what kind of soap you want. If you want liquid soap, you want to use potassium hydroxide. If you want gel soap or hard soap, you want to use sodium hydroxide because it also depends a lot on the oil, but it mainly depends on what kind of catalyst you're using. I've been using biodiesel glycerin soap now for 4 years exclusively. I shampoo with it, I shave with it, I wash with it, and I love it because it moistens the skin. So there's some definite benefits to the glycerin. Okay, let's make another one.
Is one easier to clean than the other?
Not really. No. They both do a good job.
Yeah.
They both do a really good job.
I mean the glycerin, cleaning the glycerin.
Cleaning the glycerin.
Capacity and use sodium.
Cleaning it out of like a processor or
Yeah, no, cleaning it, cleaning the...
your skin?
No.
Purifying glycerin?
Taking methanol.
Purifying the biodiesel? I tend to think that sodium has a more kick. And in my experience, I tend to get better reactions using sodium than potassium. I can still make really good biodiesel with either one, but I think that's because it's a little bit more pure, because it's typically 98% pure versus potassium hydroxide is 93 to 94% pure. But I really like potassium because it dissolves in methanol so much easier. That's the other benefit. Sodium takes forever to dissolve in methanol. Okay, so I've got 10 milliliters of isopropyl alcohol. I've got 1 milliliter of oil. And we're going to use some of this. How much of this? Doesn't matter. I'm just going to put a little bit in. And it's going to turn it kind of this yellow, kind of like curry. Look at that yellow. Isn't that neat? And it's not a hazmat, and I can ship it to Canada. Phenolphthalein, I can't. And I love Canada. We've been selling a lot of stuff up here, so we don't. You guys are doing great with biodiesel. Okay, we're gonna do with turmeric. It took 4 last time, right? Here we go. Let's see what happens. It's starting to go a little red. What it does is it likes to go to it and then come back. And what it's doing is that's because it's neutralizing some of the acid. The acids are neutralizing the potassium, but then there's still more acids than there is potassium. There, we're getting to the deep red. Look at that. See how much more red that is than my one that, who's got the one passing around? Hold it up. Go ahead and bring that up here. I'll show you the difference. Thank you. So, this was kind of a purple and this was kind of a red. I don't know, I kind of like that. It's a little bit deeper red. This one's interesting though because this one took, I'm down to 7.5, which means I'm through, let's see, 2.5. So this does indicate sooner. So it's possible that if you do use turmeric, you could slightly underreact your batch, which means you may want to add a little bit more.
Will it change color more if you have 4?
What?
Will it change color more if you have the rest of the 4?
Nope. There's the rest of it right there.
In your experience, though, are either one of those indicators more reliable, do you find, as far as just...
I'll be honest, I haven't used turmeric a lot lately yet. It's something new to me. I've always used phenolphthalein, and I know it's always bang on and it works. But in a pinch, Walmart's around the corner, and if you got a grocery store and you need to make bio, you can go grab it and it'll work. So.
Phenolphthalein usually has a expiration date. Does that really matter?
I don't think so. They say that after about 2 or 3 years you shouldn't use it. However, I've got some that's 5 years old and it's still working. I will say that if you leave it in the sun or if you leave it in the heat, because it is dissolved in some isopropyl, that'll throw it off. So keep it in a cool, dark spot away from things. You see this, I think he said this was, what, a couple years old?
Yeah, that is. So what's interesting, it still works, but I wonder how the comparison to new phenol.
That's true. I don't have any new phenol. So when I did the test with my new phenol, though, these were really close. And so
yeah, it could be
that may be going bad. Okay, so that's titration. So now how do we take the titration and make biodiesel out of it? Well, remember, titration said that number was, we're going to go with a 4. So it took 4 milliliters of titration. Well, what do we say? 4 and 2, half will come in the middle, we'll go to 3. So it took 3 milliliters of titration solution to make to neutralize this. Let's talk about the recipe and how we calculate this.
What pH did the turmeric change at? Do you know what it's?
I don't.
Okay.
I don't. I'd have to go out and pull it up. There is an article on it where someone compared it, and my guess is that it changes color at a lower pH than phenolphthalein.
So it'd be slightly more accurate, like it's closer to 7.
Uh-huh.
Okay.
Okay, I don't have a whiteboard, so I'm going to just do some math with this. I'm going to try and do it really big. When we make biodiesel, there is a known amount of catalyst that it takes to cut the fingers off the glycerin molecule. If you're using sodium hydroxide, that number is 5.5 grams for every liter of oil. If you're using potassium hydroxide, it's 7 grams for every liter of oil. Now I have to caveat this and say that these numbers are for used oil. If you're making it out of brand new oil, the numbers are slightly lower. But since we're all going to be playing with used oil, those are the numbers we use. Where those numbers came up with, someone did lots and lots of research one day and did lots of tiny little mini batches, and what they found is those are the numbers that best represent how much it takes to cut those off. Also, those are numbers based on pure sodium hydroxide or potassium hydroxide. Yes?
Is this addition of the lye, so it's not for acid neutralization, is it, strictly speaking?
When we're titrating, that's what we're doing.
Yeah, so wouldn't it, instead of having these roundabout numbers of 5.5 grams and 7 grams, wouldn't it be more precise to use molar ratios?
It would, and if there is a method for doing molar ratio titration. John in the back could actually tell you the math behind it. For home brewers, we don't have, doesn't matter, because we can always, the rule of thumb for biodiesel titration is if you don't think you're good enough, add a couple hundred more grams. Because you just push the reaction.
Yeah.
So you can be kind of sloppy with titration. You want to be as accurate as you can, but I don't have to be super accurate. I don't have to have a super accurate scale and stuff to do it. To make the titration solution, you do. Good question.
Okay, it's just, I'm used to doing lab work in university and stuff. And
yeah, university's like, yeah, that's
tenth of a mole concentration.
This is the stuff we do out in the garage, and it's, yeah. But you're right, there is a more accurate method to titrate. This is the homebrew method. So.
If you're just adding, the arbitrary extra amount, is that more likely to create soap at the end of the equation?
Depends on your oil. If you don't know what that oil's titration was, if the oil was really titrating high and you always had the same amount you threw at it, no. You might, well, you get a little bit of soap, yeah. You'll always get a little bit of soap if you're neutralizing it, but if it titrated high, you're still not going to get good biodiesel because you didn't, what happened is a lot of those free fatty acids went after your lye before they ever got around to going after these here. So I don't like unless you absolutely know your oil is the exact same, every single batch after batch after batch, and oh, one day the cook decided to pour soap in your oil and it threw it all off, but since you're adding the same amount, you don't know. I titrate every batch of oil I make. Always have. So there's a lot of people that get away with not doing that, and then they call me like when they run into the bad ones, and the first question I ask is, what was the titration? And titration is just, it's so easy to do that it really helps you understand where your oil's at. Okay, so we've done 2 of these. We were getting to the math. So 7 grams of KOH or 5.5 grams of NaOH is how much it takes per liter of oil to make biodiesel out of oil that has no free fatty acids. None of these puppies broken off. And if you're using absolutely pure chemicals. The way that we adjust, and it's in this document down near the bottom, is you take the purity of your chemical and you take these numbers and divide by it. So 7, I know that this is about 93% pure KOH, and so I take 7 and divide it by 0.93. That's going to give me roughly 7.8. That's the new base amount. And when we refer to base amount, how much oil, how much of this stuff would it take to make biodiesel out of it? So 7.8 grams if my oil titrated at 0. Then what I do is I add to it what the titration value was. We said it was 3, so 7, 8, 9, 10. 10.5. I'm going to kind of over-catalyze this batch today and go with 11. So I'm going to add 7.7 grams for every liter of oil I make, plus the 3, which is 11 grams per liter. Looks like I only had 500 milliliters. Does someone have a calculator on a phone or something sitting there?
Sure.
Cool. Let me tell you some math I need done. Well, 11 divided by 2. Never mind. 5.5. 3 is 5.5 grams. Wasn't as complex. To make biodiesel, if you've been online, you've probably heard of the Dr. Pepper method. I hear Dr. Pepper makes the best 2-liter bottles. I don't know what this one was, but this is called a mini batch. And this is probably what a lot of you wanted to come see. We're going to take usually a liter of oil. You heat the liter of oil up to 100 to 120 degrees Fahrenheit. I don't like to go much hotter than that. We heated this up to about 130.
130, yeah.
Yeah, and it's still good and warm. I'm going to make a half-liter batch, basically.
Is that small amount of moisture in the bottle going to cause?
Yeah, but I'm going to whack this thing good and hard. Remember I rounded up? Okay. So instead of adding 5.5 grams, I'm going to add 6.
Okay.
I'm going to really whack it. So I add biodiesel. The recipe is 1 liter of oil, 20% methanol, so 200 milliliters of potassium or sodium hydroxide or potassium hydroxide, depending on what you're playing with. They've gotten me 200, but I've got a half batch, so I need to measure this out to 1. Have milliliters on it. I think it does. Let's see what half is. 2, okay, I'll knock it down to 1. Because I'm doing 500 milliliters, 0.2 of that is 100 milliliters. So 100 milliliters of methanol. I'm going to measure out 6 grams of potassium hydroxide. And the fun happens, because some of you guys get to participate. Okay, 6 grams. Perfect. There it goes. Okay, you take the methanol and you mix around the potassium hydroxide or sodium hydroxide. This is going to take a little bit to dissolve. If I was using sodium hydroxide, we'd be here a long time. We'd be here tomorrow, well, not quite tomorrow, but it takes a long time. This will take about 5 to 10 minutes and we'll get it all dissolved and then we'll start making biodiesel out of this. While that does that though, we're gonna play with some other things. Set that aside while that dissolves. Okay, how we will make this batch is we will pour this into here and then we shake the living snot out of it. I'm gonna pass it around, let you kind of shake it while we're doing it, and then you let it set, glycerin settles out, you remove the glycerin, and you've got biodiesel. And that's as simple as it is to make biodiesel, which we'll see in a minute. What we're gonna talk about now though are how to test the fuel on a homebrew scale so that you don't have to send it off to a lab to see if you've got a good idea of whether you've got good fuel. And the first one we're going to do is called the 327 test. How many of you have heard this test? Okay. Give you a little bit of background on this test. This is B100 fuel that came from commercial facility?
That's right.
Okay. You get to see how good this is right here. Who made this? Are they in the room?
No, they are not.
Oh, cool. We get to see how good this fuel is.
Sacrificial lamb.
Yeah, for them. Let's hope it passes, huh? Smells good. Passes the sniff test. Just some history on the 327 test so you understand it, because there's some misconceptions about it. About 5 years ago, yeah, I guess it's been that long, a gentleman over in Sweden figured out that methanol will dissolve biodiesel that is well reacted at a certain temperature. And the things that he found was if you take 27 milliliters of methanol and you put 3 milliliters of biodiesel in it and shake it and let it settle for a little bit, if all of it dissolves, it means you have whacked off effectively the majority of these free fatty acids and made the majority of them into biodiesel. You'll never get all of them, but you've gotten it down to the level that in the United States are ASTM standard. Someone else took that and says, well, let's see how accurate that is. They got a gas chromatograph and they made a bunch of batches of biodiesel that they knew would pass ASTM. They actually put them in a GC and they measured it. And then what they did is they did a bunch of 327 tests and they measured the temperature of the methanol at different temperatures. They heated the methanol to different temperatures and the biodiesel to different temperatures, and they did 327 tests. What they found is if your methanol and your biodiesel are both at between 68 degrees Fahrenheit to 72 degrees Fahrenheit, this test correlates extremely tightly to running your fuel in a gas chromatograph. That's the tool that the ASTM standard on the commercial scale uses to test fuel to see if it's within specification just for the how well did we react the oil into biodiesel standard. It's the total and free glycerin standard, okay? So with that in mind, and I'm assuming we're about that, we're probably a little hotter in here than that, but we're good enough for what we need to do for this test. To do this, we can use our same little syringes. We're going to use, wash this one out with some isopropyl. You can reuse syringes as long as you wash them out really, really well. Okay. So to do this test, 3 milliliters of biodiesel in 27 milliliters of methanol. All right, do I have an extra one left? Alcohol in that for a second. I found these really cool vials a couple of years ago that are perfect for this test because they're marked at 27 milliliters. They're at 30 milliliters.
They're like maybe about 10 minutes to
Yep.
allow for about 3 minutes of questions after.
Okay. I say that's dissolved enough. What do you guys think for this demo? We started we got started a little bit later, so you know what? Y'all can help me shake that up while we go through it. Normally, all of this should be dissolved. You can see that not all of it is. So I'm going to kick it a little bit. I got a little bit of later of a start than we would like, but okay. That should be good enough.
For demonstration.
For demonstration, my goal is kind of to make some slightly underreactive fuel. Later on tomorrow, we will test it and see how well we made. But for this, if I can get this lid on. That is a tricky little lid. Okay, I need everyone's help. Take it and pass it around and shake it. Give it a good shake. And go ahead and pass to the next person. Pure methanol is here. So these little vials are cool because they've got the 30 mark on them. So I just put 3 milliliters of biodiesel in it and just fill this up with methanol until it hits the 3 mark.
What material are those little vials?
Huh?
What are the little vials made out of?
Plastic, just HDPE.
Could we use them to store batch samples of biodiesel?
I have lots of these at my house with samples stored. If you go into the garage or the lab of most biodieseler homebrewers, they have lots and lots of past samples hanging out.
They're all in
It's-
jars, that would be a little more
They're
compact.
all in jars or different things, It's just because we like to see what we've made and where we're at. And I bet this isn't going to pass because it had a little bit of oil residue. We'll use one of these other ones. Okay, this will be good because I can show you what fail is going to look like. So we're going to let that sit for a minute. We're going to use one of his glass tubes and redo this test again. Again, 3 milliliters of biodiesel, 27 milliliters of methanol, there's 10. I don't think this fuel's gonna pass. One of the indicators pretty quickly on that you'll find when you do this test is if it goes immediately cloudy, that's usually not a good sign. Usually it goes-
Sign of FFA or sign of water?
sign of unreacted fuel.
Is it the cloudiness or is that the level of oil you get as the unreacted fuel? The cloudiness is going to be it's like glycerin or soaps.
Cloudiness is sometimes soaps, but I'm assuming this was washed fuel, wasn't it?
Well, one might assume, but
If it wasn't washed, then that could throw it off, but
yeah, it actually may be sitting around for a while. That may be an older sample, so that's another thing too. Is like
yeah, older stuff will cause that. Well, it is kind of
when you get
dissolved.
acidification, get the acid number changes.
Huh?
Acid.
Acid doesn't affect this test, because this is just methanol and
Oh, yes, the
biodiesel.
flip test.
Yeah, the flip test can do that.
Yeah, yeah.
So, well, actually it doesn't look too bad. Yeah, this quickly dissolved. We'll let that sit for a little bit. Okay, we'll let it sit for a second. The pass is you want 100% of the biodiesel that you put in there to have dissolved into the methanol. And the test I do is I let it sit for about 5 minutes and I turn it on its side. Who's got a watch? I'm seeing 322 here. Is it
Yeah, that's about right.
322?
Yeah.
Okay, good. So we've still got a little bit of time we can play with. If you look real close, I'm starting to get a little bit of pooling in the bottom of this. And that's telling me that this, for some reason, is unreacted a little bit. Now, this is the vial that had a little bit of a residual oil, so that might be part of it. But we'll let that sit for a second. Cool. Has it gone around the room all over? One more shake, and then we'll let her start to settle. Hopefully. Sweet. I don't know if you saw, it went different colors. It went carnal. It did different things. That biodiesel will normally do that. We'll let it settle now for a bit, and we'll see if we can get some settling on the bottom. Okay, to do a little bit of review real quick. So we did a titration. That measured free fatty acid. We did the solution. We made a mini batch. We've talked about the 327 test. Let's talk about a soap test. Then we'll be done. Then I'll save some time for questions. And then this stuff will settle. When we make biodiesel, I always do a 327 test before I wash it. Because if I didn't knock off all those free fatty acids, I don't want to start adding water to it because it's just going to start making a mess. And then I have to dewater it so then I can put more methanol and catalyst in it. And that'll make even more soap. So I always do a 327 test before I wash my fuel. And if it isn't quite reacted, then I'll add a little bit more methanol, a little bit more catalyst. How much more? My rule of thumb is I always do 30% more of what I originally started with. So if my batch originally asked for 1,000 grams of potassium hydroxide, I'd add another 300. If I used 100 gallons of methanol or 100 milliliters of methanol, another 30. Blend that together, heat my oil, back up, pour it in, mix it for 2 hours, let her settle, and then away we go. Or a really good way to test is to do one of these mini batches with it. After you've made the biodiesel, you're sure it passes, it looks like it's passing. This does kind of look like it's passing. A really quick and dirty test to see if you're finished washing the fuel is called a shake 'em up test. What you do is you fill a little metal jar or a little glass jar. The reason I like glass is it's just easier to see through than plastic. Plastic's kind of opaque. Then I take some distilled water. Now, if biodiesel has no soap in it, then the water won't stick to it. It should just fall right out of suspension, right? Well, soap acts as kind of a surfactant or an emulsifier, if you will, and will fall out in the water. Also, methanol will do some of that too. And John can correct all my chemistry when I'm done.
Sounds good.
And the shake 'em up test is nothing more than I just shake it a little bit and I let it settle. Theory goes to pass this test after about, normally I give it an hour and I would have shaken it a little bit harder, but we got like 5 minutes. All the water that settles to the bottom should be as crystal clear as it was when you put it in. If it's cloudy, that means that the water is pulling soap out of the fuel. And you still got soap to wash out of your fuel. Soap's one of the biggest things that likes to plug fuel filters. So that's the soap test. Yeah, that's settling out really quick too. Good.
Right, is there a critical time to leave that for to check it out?
I like to leave it for at least an hour. I didn't shake it real hard, we don't have an hour. But I like to leave it for at least an hour and come back and look at it.
And what the 327, the same thing?
327 is 5 minutes. And if you look real close at this 327, yes, I see pooling. Now granted, I kind of fouled this one because I threw a little bit of oil in the bottom there. My rule of thumb, and you'll see this on my website, is I turn it on its side and I let it pool after it sat for 5 minutes. If there is more than if there's over 1/4 of an inch of pooling in the bottom of this, I definitely am going to re-react my batch. If there's a 1/8 of an inch to 1/4 of an inch, depending on what diesel I'm going to put it in, I might do it again. If it's going in a Mercedes, I don't care. It's going to eat it. Like the older 80 to 87-ish model, it's going to eat it because it'll eat vegetable oil. Volkswagen, the older ones, I don't care. Duramax, I care because that one's a lot more sensitive engine. 6 liter, I preferably wouldn't even want to be putting biodiesel in a Ford 6 liter, but if you are, and you flunk this bad, you definitely should re-react. If you are under 0 to 1/8 of an inch, depends on what you're going to do. If you're burning your own fuel and you're okay with the fact that you might have a little slight underreaction in there, go ahead and burn it. But if you're selling it, or if you and your buddy, if you're going to give it to someone to put in their truck, you sure as heck want your fuel not to pool at all, because that's going to indicate you've absolutely got all the stuff out. And you want to do this shake 'em up test, and you want to make sure that the water has turned absolutely crystal clear. Those are the quick tests. I know I didn't have a lot of time, so we made a mini batch, It's starting to settle just a hair. We'll put this over here, and throughout the rest of the day we'll let it settle, and you'll see it'll actually break out and the glycerin will settle right to the bottom. Huh?
Just put it in the sun or something?
Yeah, we'll do that.
And one just quick question, so when you're finding that you've got unreactive fuel in there, and so maybe people may be interested in how you go about then re-reacting.
You bet. I don't ever have to re-react one of these batches because this is just telling me, hey, did I get my measurements right? So I would actually do a completely different mini batch if this one's screwed up. Because what this is, before you've got let's say you got 1,000 gallons of oil and you're going to want to make biodiesel out of it, isn't it a lot easier to waste a liter of oil than 1,000 gallons of oil? So this is just test batches. It's strictly, that's what we do for it. We do a mini batch, we do our math, we check our catalyst, and we see what's wrong. Couple of things, just comment. I know I'm running short on time and then I'll answer because I think they're running late. What happens if this doesn't react? What happens if it didn't go well? What happened? What could have gone wrong? Number one, double check your math. Number two, double check your methanol. Methanol can go bad. It loves to absorb water from the air. And water in methanol means water in oil. Water in oil means unreacted biodiesel, and yada, yada, yada. So this is one thing you can check. The other thing, quite honestly, that we see has happened is most of the time people's catalyst has gone bad. For some reason or other, somewhere in its life, they left that thing open into the open air and it absorbed moisture and it just toasted it. The other thing I see that goes wrong, believe it or not, is titration solution is off. Usually those makes you put more than you need. You should be putting new titration solution, or making new titration solution every 90 days. Folks at Springboard Biodiesel did an analysis once and measured days before this goes bad. And about 90 days is when it really starts tanking.
Is that if the bottle's open and closed, or is
Closed in a nice cold spot? Yeah, it's reacting with the air. So even in the sealed container. Okay, questions?
Any way to test your actual pH to see what it is?
Yes, there's an excellent test at biodieselisgood.com, and if you scroll down, one of the blog entries talks about the method to test it.
And the same with methanol.
Methanol, to test it, you need a hydrometer. If you want to see what one of those looks like, out on my table, I've got a table out here. I've actually got a picture of a hydrometer. It's this thing that measures the specific gravity. Methanol is known to have a certain specific gravity at different temperatures. They make this device that's kind of like a thermometer. You stick it in and it bobs up or it bobs down. And you look at where it was, and then you look at a reference chart, and the difference between those two is the purity of your methanol. So if it is way off, by the way, let's see if anyone knows the chemistry in here. Actually, I'll ask John. How impure can methanol be before you don't want to use it to make biodiesel?
I'd probably say a couple percent.
Yes, that's my rule too, but I mean, you're the chemist. 97% is the lowest I like to go. If it's below that, I really don't want to be using it.
Probably better to go.
Okay, other questions?
We're doing okay, but people are in there too, so if you have more questions for a few minutes.
Okay, but and just remember, I guess there's some cleanup.
We're actually going to take this and just move it over there, and I'm going to clean it while they start. So, yes?
Different types of oils, any adjustment in the process, or let's say sunflower oil versus, I don't know, coconut oil?
Good question. The quick answer is no. The only thing is your titration changes.
Okay.
Different things. But the long answer to the question is different oils will have different properties of the biodiesel that they make. For example, if I use coconut oil versus canola oil, the cold flow properties of the coconut oil are going to be vastly different. So, good. But for titration, what we did today, no. It's all the same. Other questions? Yep, John?
I think with coconut oil or palm oil, that you may want to use a slightly different amount of methanol. This could take a lot of short chain fatty acids, but almost anything you're going to run into outside of the tropics, all the seed oils, all the animal fats, pretty much the same thing. I think it's just the palm and the coconut maybe, and that's not a definite, that's just a maybe. But I have seen different recipes, slight variations for those oils.
Don't they just slightly, they put a little bit more methanol in coconut oil?
I think it is, because I think it would make sense to me, because I think they have a lower molecular weight, so you need more methanol by
Yeah, because they're so densely packed.
Yeah.
We make biodiesel out of coconut oil and it smells great. We love it. So don't use it in the winter though.
Could you, if you suspect your catalyst is wet, could you put it in an oven and dry it off?
No. Once it's wet, it's reacted with the air, it's toast.
Okay.
Got to get new catalyst. Another rule of thumb, if your catalyst is over a year old, even if you think it's been sealed, go get another bag. It's cheap enough. So we battled that one once. So.
And how do you dispose of old catalyst?
It makes great drain cleaner.
Yeah.
That's actually what it is, it's drain cleaner.
Yeah.
So potassium hydroxide, if you wanted to, like a really greasy spot on your driveway and you diluted it with oil and put it down, it's a really good caustic cleaner. So you want to, if you have to, neutralize it or take it to a hazmat, but lye is a drain cleaner. So.
Yeah.
Other questions?
Could you talk about the flip test and what that tells you? Or what
Sure.
it tells you?
The flip test is a test that was developed by a guy. I don't know a lot about it, is my quick answer.
Okay.
If you go to make-biodiesel.org, you got to put a dash in there. He did an excellent article. He wrote all about it. He compared it to different things. It measures a lot of different things. It measures reactivity. It measures monoglycerides, which 327 doesn't measure. And it measures pH. It supposedly measures soap. I can't really speak authoritatively on it because I haven't used it. I will tell you when it came out, I didn't like it because not that it was a bad test, but because the instructions to read were very misleading, it was hard to understand. Well, it's doing this. Well, directions don't say anything on how to understand that. But I understand they've gotten better. Other questions? We'll just keep going until they come in and kick us out. Cool.
Well, that's the one question I'll come back to. So when you have a certain amount of unreacted oil, and so now you want to react the batch, so you just do another titration and...
I don't. I always
do it.
I do 30%.
30, oh, okay, sorry, I missed that then.
No, I take 30% of what I started with and I hit it. Now, if it really, really failed, like all 3 milliliters came out, yeah, I'll retitrate it and redo it. But if it's just like this, I don't know if you can even see this much. I'll pass it around, but this is about almost a quarter of an inch.
I think maybe what we can do is we can leave it on the table.
Okay, you guys can come up and see it.
Because we're gonna have to cut it now. So
Okay.
The next.
Cool.
So for folks that are still in here and talking, it's great. Take a couple minutes break. We did want to give the other group a chance to take a little break, and then we're all going to gather back in here for the next session anyway. So I just wanted to get things moving along because this next session is going to bleed into the next break as well. And then we're going to start getting cranky people at the last session, and I don't want to do that.
And so you guys can go if you'd like. This is something you can see for testing more accurately. We won't keep you in here, but this is an analyzer that takes these basic tests, throws them out the window, and this is almost as good as a gas chromatograph. It's as accurate as a gas chromatograph. And that you can take a sample of oil, put it in, press the thing, it'll tell you exactly what your total glycerin level is. It'll tell you exactly what your free fatty acid level is. It'll tell you exactly what your acid number is. So if you want to go on a commercial scale and you need something extremely accurate, there are devices on the market that are alternatives to gas chromatographs that are as accurate as gas chromatographs and a heck of a lot cheaper to use. So, yeah, $6 grand buys you a whole kit. It's over here. There's stuff out on the table.
The cold flow module will be out shortly.
$750 per test.
Yeah, the total glycerin ends up at 12 is the tube test, and free fatty acid and acid number is about 750 test. We're working on a bunch of other things. I'll admit I'm the managing director for that company, so for the biofuel side. So that we can address a lot of those questions either online or Graydon's got all the information as well on UBS.
Yeah, utahbio.com. So thank you.